Thanks, Kristophe. You guys hear me okay? Good.
Yep.
My name is Dave King, founder and CEO of a company called Exaptive. This is my colleague, Dr. Kristophe Diaz, and he's a scientific program manager at Cohen Veterans Bioscience. And so the goal today was to talk to you about this both from a technology perspective, which I'll bring, but also from a science perspective that Kristophe brings. And like Christopher said, what we're particularly interested in are big discoveries. I'm curious, does anybody know what this is a picture of? Is that on the target top slide?
Well, it's a collision cell of
Yeah, so this might seem strange because this has nothing to do with biology. This is a physics picture. This is a simulation that was done at the CERN Large Hadron Collider trying to find the Higgs boson, which they eventually found. And even though that doesn't have to do with biology, I included it because it's a big discovery. It's arguably one of the biggest discoveries ever made. And that's fundamentally what I'm interested in. It's what I've devoted my career to, is how do we create tools that make big discoveries. It's what Kristophe has devoted his career to, trying to make discoveries in the scientific field. And recently, this was sort of brought home to me in a new way because so my wife and I just had our first child, and suddenly all of these sort of trite things of fatherhood I'm finding really ring true for me. So I want to leave the world a better place for my son than I inherited it. And I think that's what comes down to discovery as well. My wife has type 1 diabetes, which is a genetic condition. It means my son is at increased risk for type 1 diabetes. This is something that I think there is a cure there, if not in my lifetime, in his lifetime. And I'd like him to get a world that has a cure for type 1 diabetes discovered, has a cure for cancer discovered, has a cure for Alzheimer's, for PTSD, which Kristophe is going to talk about. So this has made this, extremely personal, but it's just renewed this focus I've always had. And I think that that's probably why, we're all here at some level, is that we want to facilitate the discovery process, and we want to leave the world a better place for our children than we inherited it. I think if you're a scientist, well, I'm curious, how many of you guys are sort of on the science side of things, like closer to the bio side of BioIT? Okay, and how many of you are more on the technology side, the IT side of BioIT? That's great, it's sort of like a 50-50 split, which I didn't expect. I think that if you're a scientist and you're trying to leave the world a better place for your kids, I think you have a more straightforward path. Your work is about discovery, so go discover stuff, right? I'm not saying it's easier, I'm just saying it's more straightforward, right? I think that if, as a technologist, which I am, I'm a software architect, I think it's a slightly more circuitous path. We're not going to be the technologists, we're not going to be the people that make the discoveries. I'm not going to find the cure for type 1 diabetes. But what I can do is I can make the tools, I can make the environments, I can make the conditions that help the scientists make those discoveries. And so that's what brings me back to this, which is, as technologists, if we're going to try and create the right set of conditions for discovery, I think we need to understand how discoveries happen and the conditions under which they happen, and that's changing. So this is really interesting article by that's cited here. This is looking at authorship of Pubmed papers. This is the result of looking at every article in Pubmed, 24 million articles. So if you look at the maximum authorship over time, it is increasing. It's hard to see because detection of the Higgs boson just sort of screwed up the scale. Okay, those articles had 3,000 authors on it. So it's funny, they say it takes a village to raise a child. Evidently, it literally takes a village, to find the Higgs boson too. And I think this is key. If we don't just look at the maximum authorship, but we look at the average authorship, the trend is extremely clear. So if we're willing to use papers as a surrogate sort of metric for discoveries. I recognize it's imperfect, but we got to use something. Then, what this is showing us is that discoveries are not being made by 1 or 2 people anymore. Discoveries are being made on average by 5 people, and big discoveries are being made by thousands of people. And as technologists, I think that means we need to rethink the types of tools we're making. We can't just make tools anymore that facilitate a single scientist's productivity. We have to think about how we architect systems that that allow large numbers of people to innovate. And I've spent, like I said, most of my career thinking about this. I try and find other cases where these sorts of innovation machines have been made for large populations. I think civil engineers have computer engineers beat in this area. So civil engineers have been making innovation machines for large numbers of people for hundreds of years. They call them cities. You put lots of people close together in tight proximity, you get network effects, and this is the mechanism that has led to pretty much all of the IP on the planet. And so, from a technology perspective, what I'm interested in is, if this is how innovation happens in the physical domain, can we create virtual domains that have the same sort of IP creation potential? And over the last decade, I sort of watched the rise of social networks with a lot of optimism, LinkedIn and Twitter and Facebook and all this, because I thought, here it is. These are going to be virtual cities, right? Facebook, 500 million people, all crammed into a fiber optic cable, all 32 milliseconds apart, which is how long it takes to, ping somebody else's computer. That can be thought of like a city, the population density of which doesn't exist on Earth. And I thought, that's going to be great. It's going to generate tons of ideas. There's one guy shaking his head. It has not, and I don't want to completely disparage what it's done. I mean, I think there has been an explosion of creativity. I like cat videos as much as anybody else. I like sharing photos, but it has not created, CERN, Large Hadron Collider style innovation. And I think that the reason for that is that these environments we've created are not really virtual cities. They're much more like virtual suburbs. They sort of favor homogeneity over heterogeneity. And then what we need is we need social networks that are actually trying to work around idea generation. And that's why I call them cognitive networks. What's key to this is the recognition that social networks are not the same as work networks. And I think there's sort of an unfortunate thing that's going on right now, which is anytime we're sort of enamored of network diagrams in general, and we're particularly enamored of network diagrams that have like people connected to people. And anytime we create a graph that has people connected to people right now, we call it a social network. I think that's wrong. There's lots of reasons that people get connected that are not about being social. This is Google+, this is social. The reason that people like repost something by hunky surfer Jensen Taylor is totally different than the reason people responded to something that Steve Jobs would say. So an organizational network is not the same as a social network. And, that's sort of the key. I think we have to be careful about our language here. I don't think the world needs more social networks, but I think we desperately need more cognitive networks. Now, my goal is not just to give a talk that's a rant and tell you what we need, but to also kind of lay out specifically how I think we accomplish that. So I think it comes down to 4 basic principles. I'm going to explain those principles so that the technologists can maybe incorporate that into their own design work. And then, we're going to show how Kristophe and I are applying those principles in a very real-world use case around post-traumatic stress disorder. Okay, here's the first principle. Cities are about work. You might like living in the city because it is bookstores and coffee shops and all of that, but that's not why you went there. You went there because that's where the jobs were and that's where the work was. And what that means from architecture perspective, I think, for software designers, is I think you have to design for productivity first and for networks second. And it sounds simple, but I think we do it totally the other way around. We generate networks and we hope they'll be productive. We need to generate productivity, individual productivity, and then allow networks to emerge. That's how real cities work. The second sort of pillar of this is that the act of work obfuscates as it illuminates. What I mean by that is, you're writing a bunch of code and you're doing some data science and you're going to like normalize some values and you're going to compute some values and you're going to do all this stuff. You're going to get an answer. That's your work. The act of that sort of workflow often leads to a black box that is then impenetrable as to all of the design decisions and engineering trade-offs that went in. And that is a big impediment to these sorts of cognitive networks. So again, from a technology perspective, you have to design for the metadata as well as the data. The metadata about the work, not just the product of the work. The third thing is that serendipity is friend and enemy. So history is replete with very romantic tales of serendipity being key in scientific discovery, from penicillin to a zillion others. And here's the thing, I don't think there's anything wrong with that. Innovation requires serendipity. Big ideas require serendipity. If it didn't, we would have discovered it already. So I think that the key is not to say that there's no room for serendipity, but I think it's a travesty to rely on it. So we can create friction to improve the odds. What do I mean by that? There's a term when it comes to city design that's called productive friction. When you are walking down a sidewalk and you have to move out of the way of the sidewalk cafe, that's a form of friction. When you have to wait in line and you end up getting into a conversation with the person in the Starbucks line while you're waiting, that's a form of friction. Cities have tons of unproductive friction and they have productive friction. And I think the key when we design these cognitive networks is to think about the productive friction we can introduce. Most of the systems we're designing today, we're seeking to eliminate friction. That's good in some ways, it works against us in other ways. And the last of the four pillars is that I just can't overstate, is that ideas are not like new monolithic entities that come out of nowhere. Ideas are new combinations of smaller ideas. And the reason this is important is that when we design systems, if we're trying to design systems for idea generation, they have to allow this combinatory play of the smaller pieces of ideas. And when I say combinatory, it's important to realize that making something modular is different than making something combinatorial. Modular just means it fits together, like AC adapters that you plug in the wall for your electronic appliances, those are modular. And you can go to, if one dies, you can go to Radio Shack and get a new one and plug it in. But they're not combinatorial because you can't take any AC adapter and plug it into any electronic device. That's combinatorial, Tetris. So don't get me wrong, I'm not saying that we need these four design principles for all innovation or for all ideas. Absolutely not. There are lots of discoveries that are going to be made without any of these principles at work. But I do strongly believe that big ideas will not succumb to discovery without these principles at play. And that's why we have Kristophe here, because one of the really, there's a bunch of big life science challenges that we're facing right now that need these sorts of approaches. And one of them is post-traumatic stress disorder, and Kristophe is going to tell you a little bit about that.
So I'm a project lead at Veteran Bioscience. And so what we are a newly formed 501c3 charity, and our main mission is to fast track the development of new diagnostic and therapeutics for the millions of veterans and civilians that are suffering from the outcome of trauma, whether the trauma is psychological or physical. So we work in post-traumatic stress disorder, we also work in traumatic brain injury and all the associated comorbidity, which are multiple. And so to put things in context, I wanted to give you some numbers, and you don't have to go through all of them, but it's a very important problem that we're facing, and there's a couple of numbers I wanted to focus on here. I guess we do have a laser. Just all those more. So women are twice as much likely to develop PTSD as men, so there's a very interesting biological underpinning there, or genetic concept associated with that. 8% of people that will develop PTSD at some point during their lives. So exposure to life-threatening trauma is something ubiquitous, and the changes that this trauma provokes in the brain becomes real pathology that we're trying to address. So we also focus on TBI. You see here 1.7 million TBI in the US are reported annually, and this is underreported. There's a lot of issues associated with mild traumatic brain injury and repetitive traumatic brain injury. We start to be in the news a bit more now with some of the famous football players are starting to talk about those issues.
So is playing football the major cause of TBI?
I think it's bringing it in the news. It's not the major cause, it's just everyday life. So it's one of the major cause of death for people under 40 years old, meaning it's your lifestyle, if you're a motorcycle, car accident, etc. But also exposure to mild shock, and those are just being now monitored. In RV, for instance, in the training course, you're often exposed to multiple blasts during your own training, just by learning how to shoot a RPG, for instance. So there's a lot of awareness now that's being built around that. And those questions just underline the fact that it's a complex system, because we still don't know how to define strictly the pathologies, and you know that you need to be able to define them in order to be able to tackle the problem from a biomedical point of view. And this is a slide that my CEO always likes to show. It rattles the crowd, especially if people are working in that field. There's zero approved diagnostic, zero approved therapeutics for TBI or suicide. And we are working on comorbidity and suicidality. It's a high comorbidity with PTSD and TBI. And there are no personalized medication that address the real biological root of PTSD and TBI. And so our approach, it's trying to move away from the standard way to develop new therapeutics. And this slide here shows an example of some of the methodology we are developing to tackle this scientific challenge. We're not trying just to understand PTSD or TBI, we're trying to also develop methodology to understand and quantify brain health. In order to understand a disorder, you also have to have clear control and clear methodology in your approach. So this is one of the projects that we're running that is trying to use real data that comes from the real world, which is a big issue, and I know a lot of pharmaceutical companies are trying to develop this as well. We're trying to integrate data that come from a person using several types of sensors. We're working with patient-powered networks, and we're also trying to integrate biological marker here and multimodal biomarker that comes either from brain imaging, genetics, so proteomics, all the omics data, and also some less used biomarker such as microbiome here. And so as you can see here, it's something that we're developing pretty quickly, and we're not wasting time. We started a year and a half ago. This slide shows some of our investments in our initial effort to use the reference that we're focusing on. We're building the city around this problem. We have invested more than $60 million in research programs. We have 50 alliance partners, funded 40 grants, and have established 4 national public-private partnerships. And a few weeks ago, we announced a really exciting partnership with the VA that will help us and collaborate with us to develop biomarkers for PTSD. So we are building the city and just getting started on that. Those are some of our partners, and as you see, they span the gamut of interaction, whether they're academic institutions, industry partners, and Exactive is right here, or DC's foundation or other type of foundation all over Europe. I'll point out IMEC is developing a lot of interesting sensors, and we're working with Early Signal to develop wearables. So as you see, the city we're building is very diverse. We're working with all those different groups, and so when we accelerated this a few months ago, my CEO, Magali has known Dave for quite a long time and knew that he was working on this concept of developing a cognitive network. And we wanted to implement this platform to make sure that we don't, as I like to say, miss any kind of opportunity that will exist in this heterogeneity there. There's a lot of people that work on similar things, or people that never talk to each other, and we bring them around the same table. We want to have a technological platform to be able to capture those interactions, not just at the people level, but the type of data they work with, the type of the interaction that they're creating. So we started the City by the Cognitive City. It's launched that in January internally, and this is how the city looked like. It started to be, it was pretty lonely. It was me here that was under this node, and you can see Dave will tell you more about everything else there, but this represented the first application that we developed, and then this is how the city started, and Dave will show you how it grew.
First there was Kristophe, when we think about this sort of cognitive network, we tend to focus on just the people, but going back to sort of my first pillar, which was about productivity, people come to the city to do work, and so at Exaptive we have this concept of data-centric apps, and so we call a data app, we call it a zap, so hence the little lightning bolt and zap bit. So the first productivity tool that we worked on is we wanted to make a zap that would actually draw people into the city the same way that you come to the city because it has a good job. And so this is an example of, to give you a sense of some of the complexity, and you'll hear Kristophe narrate this. This is the knowledge map zap that we built. If I can figure
looking
out.
at the 4 or 5 concepts that we've picked, and it compares it to all the concepts that exist in the model, in this case around 1600. And it's looking at what path exists, if any, between the concept that you chose and all of them that are in the model. Just to give an example, if you pick up this one, you see how do you go from dopamine to this other concept. You can go between those two concepts, get different paths. And this represents biological experiment and results that we've produced in literature.
So again, the goal is to start with just individual productivity by giving people the ability to just be able to navigate a disease model from the sort of complex interactions to the Pubmed research. But you'll see that that's not the only node in this network. There's also these other sorts of nodes. And one of the things I talked about was the importance of not obfuscating metadata as people do work. And so it's very important I believe in building these cognitive networks, that all of the tools are built using very discrete building blocks of algorithms, data sets, and visualizations. Those are sort of your key computer science, 3-tier architecture. So how do we have that play out in a cognitive network? Well, the first thing is don't abstract them away in sort of a hidden box here. Allow it to be seen that when we started with this application, we had one data set and an algorithm and a visualization. That's your simplest application. And then over time, this evolved. So, actually, this is the next piece. So, right, so the second piece is people don't need productivity just from the perspective of one application. They need to be able to use all of those different components. So I think an important part of any cognitive network is some aspect of a catalog or a store or a repository. You see this being built in lots of different incarnations. And this is sort of the version that we built where people could access finished zaps if they just wanted to use an application. They could also access the components underneath them, just the data set, just the algorithms, just the visualizations, so they could make their own derivative works. And I don't mean derivative in a pejorative sense, I mean derivative in sort of like an idea collaborative sense. Here's the other piece about not losing metadata in the act of work. The traditional act of programming really is that you write a bunch of code, and then you compile it, and once you compile it, no one has any idea what's inside. And so a key part of the cognitive city that we've put together is a data flow programming environment that keeps the individual components that are put together into an application visible. And I'm showing this to you just as one possible approach for you to think about in your own design work. But what I think it illustrates is that this set of connections builds a finished application, but that application can then be interrogated to see the individual components that went into it, and can be annotated and versioned much like a lab notebook as people work. Here's an example of this being used, and I think this will illustrate why this is so important. So let's say somebody comes into the cognitive city. Is this playing? Yeah. And they want to do something new. In this case, they're going to bring in some components. That can be a simple text box, or it can be, a Pubmed component that accesses the NIH API. And they can bring in a visualization like a word cloud, and they can connect these components together to allow them to sort of experiment with different ways of accessing data and different ways of looking at it. And notice that this isn't involving programming, and that's because I think one of the challenges in cognitive networks is your subject matter experts are not your programming experts. And if you create too complicated of a feedback loop between that, if every time the scientist wants to explore something new, they need to wait a week to get in the queue with the data scientist or the programmer, you don't end up doing things more slowly, you end up not doing them at all. So, so this was really the key of just productivity first and network second. Now, what's nice about this is we're collecting all the metadata about how people build these applications, how they analyze data, and what that means is as people are drawn in, we can see the city evolve. So this is the slide we started looking at, that's Kristophe. Notice there's a little green box around him. The blob around a person represents their organization affiliation. So that is just Cohen Veterans Bioscience. I'm not having luck playing these videos. Okay. So now what we're going to do is we're going to start to see the evolution of this city. So this is Frank Evans from Exaptive, who's a data scientist. He's bringing a bunch more assets into the city. As he does so, more people on the CD Bio side start coming in, and they start collaborating on different applications. So now we have more than the knowledge map. And as we have more, we start bringing in other people from other organizations, just like Kristophe was showing, academia, industry partners, foundations, and we can start to see the evolution as people, a large group of people sort of rally around that main application that I showed you, the knowledge map, but we also see groups of people that are starting to converge around other applications. So we're starting to get this bird's eye view of a community coming together. The power of this is that, oh, you have a question there?
Yeah. What does it mean physically to become a part of the city? Is there, I found you're doing this work, I want to be included, then I get an invitation back, or is anyone welcome? How do you?
Yeah, let me repeat the question. So what does it mean physically to be part of the city? And I think, it's a great question, because I'm using this physical metaphor, but we're doing it in sort of a non-physical space. And so, in this case, because Cohen Veterans Bioscience is doing this very large collaborative endeavor, and I'm going to mention this on my last slide, anyone that would like to be part of this endeavor can get an access code from Kristophe, and your avatar will show up in there, and you can be part of this collaborative network. I think it's also important to recognize that this same approach works inside proprietary organizations as well, because we're taking a look from sort of a large global collaboration, but a large pharmaceutical company is sort of a city in and of itself with thousands of scientists all over.
So could they get to browse the network before they decide to ask Kristophe for the access code?
Yeah, so one of the question was, can I browse before I ask for the access code? And this is an advantage, I think, of virtual cities over physical cities, in that a lot of scientists are introverts. And and a lot of academics are introverts. And academic institutions hire, people because they're experts in their fields, and those people want to focus on what they're doing, and then they try and get them to go to like social mixers and stuff to meet their colleagues, and it's not always the way that scientists want to interact. So the ability to sort of peruse things privately and decide if you want to go to the party, so to speak, before you show up, is important. And this system that we're showing you here, this is still very early, so this is going to be released very broadly in September at a summit in Washington, D.C. And what you're seeing now is just the beginning of this. And this is part of the partnership between Exaptive and CD Bio, is that we're going to be adding all of the features like this that people need, like sort of private viewing. But
Stop the wrong people going in.
this is a challenge that all networks have, yeah. And so there's, I'm going to give you two answers to this. One is that we do have reputation system type implementations that are being put in, scores and things like this. And those things are imperfect. And the way I really want to answer your question is actually at sort of a more meta level, which is that, I don't know, I'm an engineer by training, and one of my favorite phrases about engineering is you can have anything you want, you just can't have everything you want. And part of the way I think that manifests is that every solution has problems, and I think it's interesting to think about what are the better problems to have. And so, you know, the situation we have today with sort of a lack of cognitive network is I think we have the problems, like Kristophe was saying, where he assembles this sort of big heterogeneous group, but feels like maybe there's missed opportunities in that heterogeneity. That's a problem. Now we start to create systems that sort of make it easier for that heterogeneity to get connected. We're going to get a new set of problems, you know. And I think that, and I actually think the only way we're going to solve those problems is by not being scared to let them surface, and then we'll sort of come up with the best solution. So, you know, the same way that eBay and Amazon and all of these tools frequently started with not the level of sort of reputation that they needed, but they evolved into something relatively good.
Yeah.
I'll tell you what, let me just keep going and then we'll get a couple more.
Sorry.
No, that's okay. I'm pleased that it's generating ideas. So so one of the things I want to show here is that we've got these we've got these blogs outlined by organization, and one of the things that we frequently talk about in these large collaborative endeavors is sort of breaking down silos. I actually don't think the goal is to break down silos. Silos, I think, are extremely useful. Specialization is important. People need to be able to focus. I think the question is, how do you bridge silos? And there's lots of different types of silos. This is, these could be called organizational silos. But if we reconfigure this network, we can also group these by discipline, and we can create new boundaries in which these blogs represent the different disciplines that we now have in this cognitive city. And we can see, there's the genetic epidemiologist. Where I think this becomes interesting is that each of these silos creates its own geography. So if we pull all of the different disciplines to the periphery, and we go back to looking at organization, look down here, two people that were in the same discipline, but they're in two different organizations, or an organization that spans two different disciplines. We can also look by project. So this is going back to organization, but this is by project. And so this gets to the heterogeneity that Kristophe was talking about, which is, this large green project is GWAS, and it has members from all different disciplines and from all different organizations. So we're driving to the end. I'm gonna wrap up with this slide here, well, actually just a couple more, which is that I think the key is not just to bring these people together, but to create the right sort of productive friction. So what do we do once we have this bird's eye view of a cognitive network? Well, what we want to do is bridge those silos. And so we can actually create facilitated interactions that will send emails to the people in the city based on things that they have in common. And you can see that now we've got this dotted line, which represents an act of facilitation by the program manager and eventually by other members of the city to try and bridge these collaborative connections. And so we can continue to build out these lines in which we start to try and create more cohesiveness. Now, what good is that? Well, let's go back to this view. You remember that I talked about the importance of having productivity tools. When those people that have been part of these facilitated interactions come back into their work console, they now have the ability to associate the work that they've done with some of those facilitated interactions. So they can say, oh, the thing I'm working on right now is based on the conversation that got brokered by Kristophe with this other member. And the reason that's so important is that we don't care about just making these dotted lines. What we care about is seeing that new work is arising out of it. And so as people attribute, just like citing papers, as people attribute the work that they're doing to these facilitated interactions, certain parts of the network get darker and wider, representing that that is fruitful collaboration. So those are the 4 ideas. Give people productivity. Make sure you don't lose the metadata. Use the metadata to build a network automatically for them based on what they do, not what they say. And then allow them to play combinatorially based on the connections that they make. So if you guys would like to participate in any way, please feel free to contact either of us. Thank you.